Okay, well, this is me in my classroom, and the goatee, by the way, is literally just for my Halloween costume. I kind of look like Gordon Freeman from Half-Life, if you've ever played that. But I do want to talk to you about like a real application of physics, because it does appear in your everyday life, and one real application of it is if you understand, like, you know, especially with the Halloween season coming up, is that you're going to have a lot of competitions. A lot of companies are going to do competitions where they're like, hey, guess the number of jelly beans or candy corn in a container at any, for any point. And a lot of people are thinking like, okay, well, I'm just going to guess, right? But I'm not going to guess because I'm a man of science, right? So what I'm going to do is we actually have a competition going on in the science department right now, which is to figure out how much candy corn is inside of a 1,000 milliliter flask, and the Erlenmeyer flask. And the question is like, so how much candy corn is in there, right? And I'm thinking, well, my first train of thought was automatically, right, the easiest way to do it would be to take the mass of the flask with the candy corn in it, and then figure out the mass of a single candy corn, and then you would figure out the mass of the flask, and then figure out the mass of the flask by itself, subtract the difference, right? And the difference will be the mass of the candy corn, and then you figure out the mass of a single candy corn, you figure out, okay, how many candy corns are in there, except you're not always going to be able to just measure the mass of the container, so I'm going to show you a different, possibly more viable way to do that, okay? So what I did was I purchased candy corn from the store, okay, and what I'm going to do is I'm actually going to follow the procedure almost exactly from a density activity that we did in Physics 1, okay, where what I'm going to do is I'm going to take a graduated cylinder. This is a big one that's 500 milliliters, and I'm going to fill it up with just a small amount of water. So maybe I'll fill it up to, let's go the 100 line, because I don't want to put too much water in it, okay. So what I'm going to do here, oh, that is way too much water already, okay. I'm already sitting a little bit over 100. I probably should have filled this up before I started the video. Now I'm a little bit under, okay, and you're just going to play this crazy game of try and get as close to 100 as you can, okay, and I again overshot it just a little bit, okay. Now I'm going to empty it out. Ooh, that's like perfect right there. That is like perfect. Oh my gosh, that is incredible. If only you could see that better, okay? That's right about 100. So the volume with 0 in it is going to be 100 milliliters. That's my initial volume, okay? And what I'm going to do, okay, is I'm going to then take the candy corn. I'm going to take like 5 of them, okay? What I'm going to do is I'm going to take 5. So here's 3, okay, and here's 2. Okay, I'm going to take 5 candy corn, I'm going to set them on a scale and get the mass of the 5. So now I'm adding 5 candy corn, and the mass of that is 8.29 grams, okay? So then what I'm going to do is I'm going to add them into the graduated cylinder, and I can figure out the water volume from there, okay? So then, okay, add them into there, and the new water volume reading is approximately right about actually 100, maybe 100, and let's see, it goes in increments of, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would go in increments of 5. So about 106, I'm going to say 106 milliliters, okay? And you're going to do this over and over again until, so I'm going to add 5 more, okay? There's 5 right there, okay? So I'm adding 9.78, okay? So then we should end up getting, and I don't have my calculator with me, so I'm just use my phone calculator, okay? Which is perfectly fine because I'm not doing any crazy math here. 8.29 plus 9.78 is going to give me 18.07. Okay, this is going to be 10 I keep calling them jelly beans. These are candy corn. I like jelly beans more than I like candy corn, but I don't like either really all that much. And this is right about going to be maybe about, let's see, about 114, 114, okay? And I'm just going to keep doing this over and over again until I get like 20 marbles, or 20 candy corns in the graduated cylinder. Okay, so here we go. I'm going to get like 1, 2, 3, 4. Okay, so there's 5 right there. Okay, and then I add 8.95 to get another mass value of 27.02. This is now 15. Okay, so I'm going to add those to the graduated cylinder. Okay, and you should get, let's see, this is right about, that's actually right about perfectly at 120, 1.20. Okay, or sorry, not 1.20, 120 milliliters. Okay, I'm noticing it's pretty. It's not pretty consistent. It's about 8, and then about 6 right there. Okay, so it's not super consistent because the volume of these isn't super consistent either. Okay, so then that gives me. Okay, so there's another 5 right there. It's plus 8.76. That gives me 35.78. Okay, and this is for 20 of them. And then when I add those into the graduated cylinder, okay, and there's like some bubbles, so it's actually making it a little bit harder to see. I'm gonna give this about, let's see, 127. It looks like it's right about 127, maybe 128. So I'm gonna go 120. I'm actually gonna under guess here, 127 milliliters. Okay, and then for the final set of 5, I bought a ton of candy corn because maybe hopefully my kids will eat some of it. Okay, there's 3. Okay, there's that. So there's 5. I'm adding another 8.15. And I get 43.93. Okay, and this is 25 of the candy corn. And now, let's see what we get here. Okay. This should be about, okay, so 100, so it's 125, 130, about 1, I'm going to say 138. I'm going to say that's about 138 right there, okay? Okay, so I've filled out my data table. I've got 5 data points. That's great, okay? I can then make a bunch of graphs to figure out the volume. So if I figure out the density, I can actually figure out the density of the candy corn from the data that I've taken, okay? If I use my regression equations, okay? So what I can do, right, is if I figure out if I do a graph of the mass versus the volume, then I should be able to actually take the regression and get the volume of a single candy corn. And then what I can do after that is if I figure out, so I'm gonna make some assumptions here. If you know like a Erlenmeyer flask, right, it's got the conical flask part and then it's got the little cylindrical part at the top. I'm actually going to cut out the cylindrical part because if you go over, you're disqualified, right? But if you go under, that's perfectly fine, right? It's like the Price is Right. So what I'm going to do is I'm going to just pretend that part up there doesn't exist, and I'll knock out some of the candy corn. And when I do my regression, I'm going to take I'm going to get the volume of a single candy corn. And when I do that, okay, once you do that, then what I'm going to do is I'm going to take the volume of the flask, which I've converted into meters cubed, which is 0.001, and I'm going to take the volume of the flask, and divide it by the volume of the candy corn to figure out about how many candy corn should fit in there. And actually from there, I might also subtract like another 10 or maybe like another like 10 or 20 just to kind of give myself a little bit of room, because obviously they're not packed in there ideally, right? It's not like the candy corn is taking up the entire volume. There are open spaces in there, okay? So that's about how I'm going to do that. But I'm just curious, right? This might be something that you want to try, and I'll obviously update in the description if I get this correct or not. So yeah, that's kind of fun, right? That's pretty cool. So like a real life application of physics. All right, peace out, guys.